Hello from Tel Aviv. I'm Dov Teini, and I'll be talking about the design of reciprocal learning between human and artificial intelligence. I'm a member of a team that includes researchers from data science, human-computer interaction, software engineering, qualitative research methods, and domain experts in cybercrime. So put together, I would say that we are rather an interdisciplinary team. Why reciprocal learning? Well, more and more experts on decision systems that combine big data and artificial intelligence are saying, keep the human in the loop. Don't go for complete automation. In other words, the human remains in the loop beyond the stages of initial machine training for all kinds of reasons. We wish to go one step further. Design ongoing reciprocal learning, not only for human experts to train machines, but machines to foster human learning too. Consider two examples. An intelligence analyst detecting suspicious communication using an AI-based text classification. We want also the analysts to keep learning and adapting their classification rules in a dynamic world, and then passing on to the machine their new insights. By the way, this is the case that we are developing in our own project that we're talking about here. Consider another example, a physician diagnosing a patient using an AI-based disease system. The AI keeps learning, but we want the physician too to learn and develop. As long as the physician is in the operating room, in control, ready to take charge in an unexpected event, the physician should definitely be capable. So given that we do want reciprocal learning, here is our proposal to enable reciprocal learning. The human-machine configuration designed with two feedback loops to enable both human and machine to learn one from another. Going from left to right in the diagram, we have three parts: initialization, the learning loop, and the outcome, which is our particular case, is classifying text messages as either suspect or not. So let's take the first two parts and concentrate first on initialization, boxes 1, 2, and 3, which basically is the classic AI-based system, which includes initial human classification of text and training the machine learning algorithm. The next part, which is in the lower part of the learning loop, is when we keep the human in the loop, so that the human builds and revises his or her conceptualization of working knowledge. Notice the spiral showing the conceptualized knowledge that develops with new experiences. Abstractly, the same knowledge is shared by both human and machine. In the upper part of the learning loop, we have our new idea of reciprocal learning, which has a feedback loop going from machine to human. It includes outcome feedback, which is high-level feedback on performance, and explanatory feedback, which is low or detailed feedback that explains performance. What are the design implications for the human-machine learning configuration? Paramount is the obvious: enable reciprocal learning with two feedback loops, one machine to human and the other one human to machine. But we broke this down to two levels: functional and communication. The functional is primarily about allocating tasks to either human or machine according to their relative performance. E.g., humans are good at sense making. The communication talks about how to make communication effective in order to enable reciprocal learning. We've already mentioned that learning requires both outcome and explanatory feedback, but additionally, explanations must rely on explainable reasoning. You cannot explain a black box. Moving from the configuration and the design to the implementation, we have developed a software we call Fusion, which is to support the HML configuration, both its initialization phases and its reciprocal learning loop. So let's just to get a feel or a taste, or even whet your appetite, let's take a couple of screens to show you what Fusion's all about. Now, on the left-hand side, you see the menu with the functionality of the HML configuration. Right now, we're in the screen, you might be able to see it, the highlighted model generation. And what we can see on the top part of the screen is the machine learning classification models. The user specifies what type of model, supervised versus unsupervised, and what conceptualized knowledge he or she wishes to use. On the lower part of the screen, the user can also compare the models and their performance. So, for example, in this particular case, we have the supervised lexicon Wikipedia model, iteration number 1, and with it we have measures of classification model performance. Let's take a closer look at that. You remember that we have 2 types of feedback, outcome and explanatory. And this is the screen. You see the outcome feedback for this particular supervised baseline Wikipedia model. And first of all, you can see the confusion matrix, which shows you the true and false the frequency of the true and false predictions. We can, just above it, also see 5 measures of classification accuracy, including the popular AUC, precision, and recall. If we look at the explanatory feedback, here we see more details of each classified message according to whether the message is true or false. We can also see the terms that the algorithm used to make that prediction. And if you look at the graph, we can see position of the particular term in that in the lexicon that user dictated. In conclusion, first of all, there's a lot still to do, and we are working on it. For example, we want to extend the use of conceptualized knowledge, and we're working on feedback from the human to the machine and its automatic incorporation into the model. Second, let me summarize what we have already accomplished. I summarize the main message as reciprocal learning with machine to human and human to machine feedback is central for keeping the human in the learning loop. And I believe we've made 2 contributions. One, the HML configuration, the figure that you see on the right. We believe this is a general solution that can, frankly, change the practice of working with AI. The second contribution is the lessons we learned from developing and working with Fusion. First, the need to support continuous learning, the need to examine alternative perspectives, the need to examine changing contexts, and the need to provide explainability in feedback from machine to human. That's it. So thanks, and I hope to see you in the live demonstration later on.